Hi everyone. Thank you for joining us today for the final webcast in our ThingWorx UI series, Make Your Data Talk, Using Visualizations as an Interface for Intelligence. I'm Clint Detweiler-Oldfer, and I will be your moderator for today's event. Our speakers today are Chris McDonald and Sveta Saul. Chris McDonald is the Senior Director of Global Analytics Development here at PTC. He has been a leader and technologist in the analytics space throughout his career and has helped companies across every vertical harness value through data-driven innovation. Sveta is a principal partner engineer on the technology platform who has served several years of experience as a professional designer and program engineer with a focus on UI and user experience. We would like this webcast to be interactive, so please feel free to join the conversation. You can post questions in the Q&A pane at the bottom of your screen, and we will do our best to answer all inquiries during our closer Q&A session. In the event we are unable to get to your question directly, we will have a team member follow up with you. If you do experience any issues listening to or viewing today's webcast, please refer to the event help guide link I will provide attendees via our group chat. We also recommend viewing this webinar in Firefox for an optimal experience. One last note before we get started. We will be recording today's webcast and will send the recording to all registrants as soon as it's made available. And with that, I'll hand it off to Chris.
Thanks, Clint. Hello, everybody. Thank you for attending. Again, my name is Chris McDonald. Today, I want to walk through, in collaboration with Sveta, a little bit about our analytics capabilities, but most importantly, I want to provide a perspective, an analytics perspective on developing against the IoT. And very importantly, when you create advanced analytics outputs, being able to make meaning of them, right? If you think about data science or advanced analytics in the paradigm of being able to, create intelligence and then be able to operationalize intelligence, right? There's challenges across each, but by the time you get to the point where you've created a model that you can trust, that you've operationalized it in terms of scoring it, right? That's a lot of work, and it takes a lot of organizational skill set and technologies, right, and commitment to do that, right? Certainly we have technologies that accelerate it, but if you get to that point and you have these valuable analytic outputs and you can't actually expose them in a way that someone can consume to make a decision based upon that hard work, well then frankly it's all wasted. And many times companies don't realize the importance of taking advanced analytics outputs and using visualizations and user interfaces to ensure analytic consumption. So to start out, I'm sure you've seen this if you attended some of the other webinars, but if you think about ThingWorx and the industrial innovation process, right? We have capabilities, certainly across this paradigm, and I'm going to get into today how to actually create logic within the platform with our ThingWorx analytics capabilities, particularly Analytics Builder and the interface to analytics servers in terms of how to create a predictive model from a historic data set. And then we'll go into really how to take that information, right, and be able to add some context and expose it out in terms of visualization, and I'll do that with the help of Sveta and her brilliant UI skills. But overall, before we get started, I kind of want to introduce how this process, right, how the ThingWorx platform, allowing you to bring in data from anywhere, being able to source and connect to information not just from the physical world, but from actual enterprise applications, traditional enterprise data stores, how bringing that together and adding context about the assets that it's connected to, the data, the information, right, how creating an application artifact, right, and then applying logic to it to be able to synthesize it in a more meaningful and computationally assistive way that allows you to orchestrate not just insights but workflows across the enterprise, right? And how all of that comes together through visualizations and engagements that allow business decision makers who are not developers to be able to experience and understand that rich information, right, is critical. But if you think about that, fundamentally, from end to end, that is an analytics process, right? If you're an analytics practitioner, right, you think about the world in terms of data, logic, and insight, right? You hear data scientists say all the time, what's the business problem you're trying to solve? And the reason that they say that, right, is that they're trying to frame the analytic question. They're trying to understand how a business problem that they're developing against or that they're creating logic for is correlated to the data that's available in that enterprise. They're trying to understand how a descriptive view can be created as a way of being able to then model, right, that data. So if you think about this paradigm, right, you start with what's the business problem you're trying to solve. You go look for data, historical data that represents or describes that problem accurately and hopefully richly, and then you decide, based upon the kind of business insights that you need in relation to the problem, what types of logic you would apply to that, right? Whether it's more simple descriptive or whether you're trying to be proactive and drive a prediction, right? It really depends on the kind of problem you're answering. But fundamentally, with ThingWorx, what are you doing, right? You're sourcing information. You're trying to be able to apply logic to that, and then through the application of logic to that data that describes that problem, you are gaining or calculating insight. So all of this, and it's important to remember as people that kind of sit on the development side of things, when we're developing these IoT applications, when we're talking about this paradigm, at the end of the day, it may be about development. It may be about an innovation process for us. It may be about how to get the business requirement met as quickly as possible. But let's not forget, all of this is without purpose if we don't realize that ultimately it's driving business intelligence. If the stuff that we are developing, if the logic that we're creating cannot be meaningfully put into operation, if it cannot be consumed by the person who's actually making a decision, then all is lost, right? The purpose of our jobs is lost. So let's keep the end in mind. Just like a data scientist would say, what's the business problem you're trying to solve before thinking about installation, before thinking about algorithms and modeling. The same applies for overall application development. What is the purpose of what I'm creating? What is this solution actually doing? How is it augmenting human capacity, not burdening it? What's the most natural way for that end user who needs to take these insights and drive a decision to be able to understand and consume them meaningfully, right? Because ultimately, IoT, particularly IoT data analytics, is about business intelligence. And let's keep that in mind before we even start developing. And that starts with, what are the questions you're asking of your IoT data, right? People always think about IoT in this piecemeal way, right? What do first I need to connect to stuff. Then I need to do this. Then I need to see it, right? The problem with that is that it doesn't have the end in mind, and with analytics, it's fundamentally important to understand what are the questions you're going to be asking of that data, because it will affect the way that you connect to, the way that you bring data together, the way that you add context to it, so it can not only be good for reading information in terms of a visualization, but so that it can be relevant in terms of the modeling and the logic that we're going to be building and operationalizing. Right? So if you start with, again, this problem and think about the kind of view that you would need from your IoT data, that is a big part of it, right? Because that will guide what kind of logic that you're going to be using. Because fundamentally, the different types of logic or analytics that you can apply, right, one is not better than the other, right? Descriptive analytics is, yes, simple calculations, but that doesn't mean that the business is getting less value from them. It means that they're trying to answer a certain type of question, right? They're trying to say what happened, versus diagnostic, where they're trying to understand causal factors, right? They're trying to understand the performance of variables against another. We're entering the realm of statistics to understand why, right? And then with predictive and prescriptive, yes, we're getting a forward-looking view, right? We're trying to understand when a problem is going to occur in the future. We're trying to drive a prediction. Or we're trying to prescriptive to understand what different levers or independent variables may or may not have an impact so we can optimize against those. But fundamentally, don't jump to prescriptive just for the sake of doing it. Think about, what is the decision that I'm making based on this, right? What is the importance of the decision? How tactical is it? How strategic is it? I always use the example, if I'm a CEO giving my forecast in the next quarter to Wall Street, I'm probably not using a predictive model to do that. Right? I need accuracy and I need to depend on it, so I'm probably doing more of a descriptive exercise. Whereas if I'm a CEO working with my executive team about business strategy across 5 years, I may be using a predictive model, right, to understand trends and what would be happening in certain regions and markets. Right? I need insight and I need something that will guide me but the criticality of that decision is different. Therefore, the forward-looking bias and potential inaccuracy of a predictive model is less important there. So again, it's not to say that predictive models are always necessarily better. It's just important to think about how they're going to be used, for what purpose. Where is the logic going to be applied in between that data that's describing the problem, the kind of decision and action that's being taken based on the insight from it. And in the advanced analytics realm, what are we doing? Right, we're taking that data, that logic, and that could be in raw form in any sort of traditional enterprise data store, but what we're doing is essentially bringing that information together. We're tidying it a little bit. We're transforming it. We're creating that statistically ready view of the historical data, right? And that data may be represented in the Thing model as well, in ThingWorx context. Then we're using ThingWorx analytics capabilities to automatically create a machine learning model. This is a supervised machine learning approach, so it's an outcome variable, right, and other independent variables that describe that problem. So predicting failure, predicting quality are common use cases, especially in the industrial space. When we have that model, we then operationalize it, and we drive a calculation. We have an analysis model, then we have new data coming in, it's data being scored against that analytics model, and you have an analytic output coming out, right? That's the key part from that calculation perspective, or what are those analytic outputs doing in terms of the application, and how are they being consumed? And in terms of the tool sets that we have, from a developer perspective, ThingWorx Analytics has an interface or a GUI built on ThingWorx that allows analytics developers to have a simple, intuitive interaction for data, right? You can load the data set up in terms of creating that model, and you can start to understand some of the complex relationships, as well as simplifying. So there's automation, right, in the ThingWorx Analytics platform for machine learning, but it also helps you understand what's going on in that process. It helps you have visibility into it. It helps you interpret not just the information that's driving that automated machine learning, but it also helps you understand and consume the results, whether you're a more advanced data scientist type or whether you're a simple business analyst that's trying to understand advanced logic, right? I'll show you that today. That's the tool that I will be working in, right? And today we're going to be doing a demonstration in terms of, hey, what does it mean to take one specific use case to create a model? And you'll see it in the development zone where someone like myself, an analytics practitioner, can understand what's going on and then interact with someone like Sveta who's saying, hey, what does this mean for the business, right? So it's equally important across the board. A data scientist starts with that business problem, defines the data, but then can get very much in the weeds in terms of the model, the accuracy, what it means, looking at these analytic outputs. And you need someone who's a different mindset in development, like a Sveta, to remind you, wait, let's go back to the business problem. Great, you have a model you trust, but what does it mean? How is it going to be consumed by someone? And that's key in this development process and really what we're trying to do throughout this session. And finally, right, in organizations that are really developing a strategy and a foundation for the industrial IoT, oftentimes they have intelligence that lives in all types of places across the enterprise that could be leveraged and used to drive more meaning and understanding of that data. Maybe it's simulation of a specific product that they're using, right? Maybe it's other types of machine learning models that have been created by their data sciences team in other technologies, in R or Python, et cetera, right? ThingWorx Analytics doesn't have a strategy of you have to use our tool to create that intelligence. What we care about is intelligence. We care about the value of building for the IoT being cognizant of analytics, being cognizant of intelligence, and we see the industrial Internet of Things and the platform as an interface for that intelligence. So we have Analytics Manager that allows you to take the types of intelligence you have across your enterprise and manage those analytic models and how they are being scored or calculated against. Right? At the end of the day, whether it's predictive analytics, whether it's prescriptive, or whether it's descriptive analytics, you build logic and then you have a model. And you're still driving a score, right? You're taking data to calculate something in that model. Now, that calculation may be a basic algebraic formula, right? When X and Y happens, this equals Z, versus something that's statistical. But at the end of the day, fundamentally and architecturally, it's still an analytics model being calculated. So Analytics Manager lets you take those different types of analysis models and be able to enable the deployment and execution and management of all of that analysis across your IoT application through the platform. So with that, I'm going to jump to my demonstration here. Press play. Is my screen sharing yet? So here I'm showing an example, and just to give you a little preface on this use case, right? This is a example customer, right? In this case, it's the customer makes and services commercial espresso machines that would be in coffee shops or restaurants, etc. Right? And in order to better provide service and that commitment that they have, right, in this use case of their customer, they want to be able to proactively understand what's driving failure so that they can provide proactive service and just optimize the way that they service their fleet of commercial espresso machines right across the board. So here we have hundreds, if not 1,000 of espresso machines, and what I did to start right is take a data set that describes those problems. So it's one machine, the machine is the same across the fleet, and there's three major areas within the espresso machine that are driving problems, right? For this example, on our side, we'll show you in the end application the three different components that we're driving predictions for. But here I wanted to take that data set, I loaded it into Analytics Manager. Here I'm in the Analytics Builder, and I have all of the different features. So I have 52,000 rows, I have 33 features. It's just sort of explaining the data set that I loaded up. It's giving all of the different features that are represented within this data set, things like cycle variances, temperature, etc., right? And I can also, right within here, identify the goal, right, or the outcome variable that I'm building that model on. So you see the different data types. Here for this example, I'm going to build a model that gives me a prediction for the probability of failure in the grinder. So grinder error occurrence is actually my outcome variable in the historical data set that I'll be using to build this model. Right, so if I go here, I have this data set loaded. Great, I've defined my outcome variable. By the way, you can check more than one if you have more than one outcome variable and you want to build more than one model within the data set. With Builder, that's kind of a nice feature there for the analytics practitioner, right? If I go to models.
So, Chris, can we see an example of those models?
Sorry, say that again, Sveta.
I was curious to see an example of those models. That seems like a lot of data. So how do we make sense of all of that?
Yeah, so that's exactly the power of machine learning, right? If you think about machine learning, it's not meant to be a magic 8-ball box. It's meant to augment human capacity, just like you said, Sveta. Right? That's a lot of data. It's a lot of features. So when you have 33 features and a depth of data, and you want to understand, even retrospectively, what's driving statistical performance of a given element like grinder type, well, yeah. That sounds like a good use case for machine learning. You have an example of failure. You have tons of other information in the past where that, what's going on when that failure occurred, right? Let's use machine learning to sift through that, to process that. So here what I did, right, was actually take that grinder failure. I had the outcome variable defined, and I actually let the technology just build the model, right? So I loaded it up, right? And if I take this model that I did, I can see right away at a high level, right? Grinder failure is what I named the model. It's based on that data set that I just talked about. My outcome variable is grinder failure. I didn't filter any of the data. I just said, what we call throw the kitchen sink at it. I used all of the data, right? And I let the model run. It took a couple minutes, under a couple minutes, and it created a model accuracy, right? That's actually pretty good. You don't want to see sometimes you don't want to see like some of these other models that are run in my builder. I can see that there's something probably going on with the model that's overfit or whatever. But here in this case, right, I can see 92% accuracy. This actually works out. I can see MSE, Pearson, and as a data scientist, I even want to go into the actual models, right? I can see the different predictive results because fundamentally what it's doing, right, in the technology, it's taking that historical data set and it's automatically and randomly taking out a holdout set of data. It defaults to 20%. So it randomly selected 20% of the data in that 52,000 rows and 33 records, right? to use as a holdout or validation set of data. It then applied that holdout set against the training set of data in order to test different combinations of algorithms-based learners and ensembling techniques over and over and over again, thousands of times, in order to try to calculate the highest statistical accuracy it could. When it finally exhausted itself, it gave me the model that was created, and I can actually go in, right, and see the model details. So I can see from a statistical perspective, some stuff that, said, I know what you're going to tell me. This doesn't mean anything. That's great, right? And frankly, this only really matters to a data scientist, right? But what they matter.
How do you present this in the most impactful way? Do we want to expose all of these portions?
Yeah, so you're absolutely right. So I think that, what I'm going through now is someone who's, again, you're right, I'm kind of getting into the weeds here, right, of analytics. I'm seeing the different base learners, that were chosen as part of the ensembling technique. But the good news is, from your perspective, the end user's perspective, what happened here, Sveta, is that I built a model. It actually looks good. It looks healthy. I can see the different learners that it chose, right? I can see the ensembling technique. So from a data science perspective, let's put it this way. It makes sense, okay? What I do think that's helpful from a, building trust in the model, because Sveta, I bet these numbers, right, this 92% or 0.28, right, or these false positives, right, I bet to you that's like, that doesn't necessarily drive confidence, right?
Not really. I would like to know a little bit in a simpler way, what does that mean? Maybe get into my application and get hit in the face with the prediction and maybe even what I need to pay attention to and what I need to do.
Yeah. So one thing that's nice, too, about analytics and some of the outputs that we have are on the explanatory side. So, and this is really something that maybe not in this visualization that I have here that's defaulted in Builder, but let me explain, Sveta, kind of what these things are and see what you can do with it, right? Let me walk through it here. So, right, what am I doing here? I have an espresso machine. It has different components. Here I built a model with the outcome variable being grinder error occurrence. So ultimately it's going to have an operation of score, right, or probability of failure occurring in that specific component, right? But all that data set that I loaded up, if you remember, all those different features, right? What this is doing in signals is something called an MI calculation. It's actually based on the information game theory. Again, non-analytics person, you don't need to know that. But really what it means is it's trying to understand the importance of an individual feature or independent variable and its effect on the performance of the outcome variable. So across this data set, if you see up top here, Sveta, right, the average goal for failure, right, across my data set descriptively, calculation, right, is about 0.18 or 18%, right, failure rate across that population of data set. And what this is doing is saying, okay, out of those independent variables, and it's not so much the number here that matters, right? What matters is the comparison between them. So this is telling me that the most important independent variable or feature that's driving over, and you can do underperformance as well, but overperformance against the average goal, right, is average daily cycles in the prior week. And as a business person or someone who's actually familiar with this espresso machine or a service person, that makes sense to that would make sense to them, right? The more that I'm using it, the more cycles that are going on per day, right? That is a feature that's driving a higher occurrence of failure in the grinder thing, right? That makes sense. So that it's not interesting, right? Quote unquote, on the surface, but it's important because it drives validation, right? A lot of times, one of the challenges is when you build all these models and there's, it can feel sometimes like a black box to the business user or end user. So I think and I'll leave it up to you, but I think it's helpful to show some of these things to drive confidence, to be like, oh, okay, what this model is doing is it's explaining this data set or history in a way that I can validate, because, hey, that makes sense to me, right? If it's being used more, okay, great, it makes sense. Yeah, if there's more, hopper jammed alert codes in the prior month, that makes sense. What I'm seeing here, too, is that grinder type, right, is also a high, feature or signal driving performance. But so these are analyzing it on its own. What's also interesting is profiles, right? And this is something unique to our analytics capability in ThingWorx. It's actually an algorithm that searches through the entire feature space of that. So that historical data set I used to build a predictive model, and those accuracies, right? Also, it has some explanatory analytics that it's doing, yes, in part to guide, some of the automation, right, and choosing those algorithms and sampling techniques, but on its own, retrospectively, it provides a ton of value. So what this algorithm is doing is searching through, right, all of the feature space and looking for hotspots. You can also train it on cold spots, but here hotspots, right, of overperformance. So specific prolific examples, right, of when you combine features and their values, right, that drive, right, a higher than average, value against the goal. So here, if I have an 18% probability, 18%, right, or the average goal for grinder failure, right, what are examples where that average goal is driving up, right? So if I go here, I can look through these profiles, and so maybe it'd be helpful if I just give you an example of one that's interesting and what's powerful about this, right?
Sure.
So if I go to
example. Mm-hmm.
So profile 7, right, how I read into this, right? What is it doing? So what it's saying to me here is that it searched through this data set, it found an example of profile 7, right? And like we were doing before signals, right, it found to start with, if the grinder type is satellite, right, and I'm not the domain expertise, but, that's a certain type of grinder type, right, that they use, that on its own, right, leads to a 0.15. So on its own, right, that's actually lower than the average. So that's not particularly interesting. But what the power of this technology is really an example of the power of machine learning in terms of, being able to describe historically, is that it's saying, okay, so that's 15, but if I add, right, if the grinder type is satellite and the average daily cleanings in the prior week, right, are between 0.75 and 1, well, suddenly, when I added that feature between these values, it jumped to 0.48, which is significantly higher, right, than the average for the goal. Right, so what it's doing, and you can see it, the technology automatically down-selected records. So yes, I'm going from 16,000 examples of this down to 1,354 examples of this, only 2.5%. But this 2.5% population of records, right, has a 48%, right, example, right. But when I add in on top of that, so if the grinder type is satellite and the average cleanings in the prior week are between this, and the average daily cycles in the prior week are between 310 and 377, I see another jump. I'm getting a 65% chance of failure, right, when I have these conditions happening. So yes, 646, set of records, but if I'm a service manager, all of a sudden, right, and I set the depth here to 4, right, but even this recipe, literally, if you think about profiles, this prolific example of statistical performance against the average goal, I want to investigate how those things are happening, because if I'm seeing, even though it's 646, number of records, if it's leading to a 65% chance of failure, right, there's something about that recipe that myself as a service manager wants to investigate. Maybe there's something fundamentally about this grinder type and the way that people are cleaning it, or what's going on with a certain cycle rate. There's something systematically that's worth examining, and so I can act on this right away, which is nice, right? So not only is it validating this, and it's providing something deeper than the obvious of saying, hey, when I run more cycles in the prior week, there's a higher chance of grinder failure. That's great, right? And I want that. I want that trust and validation. But I also want to go to the next level. How can machine learning tell me something that I wouldn't know? How can it augment my capacity to sift through historical data sets and find exact examples, right? How can I use statistics and the power and computation of machine learning to dig into prolific examples of something? That's powerful. Does that make sense, Sveta?
Indeed, it does. That seems like a lot of valuable information. These profiles seem like really invaluable examples of what could cause issues. I'm trying to think about how we can visualize this in the best way possible so we can create a really meaningful interface for the end user. And it seems like we have some important points that we need to demonstrate right away. And if this is a good point, maybe we can take a look at an application that we already have. And
yeah. And I think this application you're showing has the full 3 models in it, right? So this is just one of the models that I built, but I think that you're going to show all 3, right?
It does, yeah. We do have
awesome.
a few models included as an example. So this is an application that was designed by a professional, experienced graphic designer, and I just wanted to make sure that we are exposing all this amazingly valuable information from the model in the proper way. So it sounds like knowing the risks and the potential failures is probably the most important thing that we want to show right off the bat. So here we have a lot of grinders located throughout the U.S., and we are able to see and kind of rank them even based on the potential failures. And we're looking at
so these are actually, so this is when it's being scored, right? So here I'm seeing a map of, you've taken all of the espresso machines that are in play here, right? We built 3 different models, and actually you're running a scoring job against them. And for each of those machines, it's giving me a prediction, what the probability of failure is for the heating element, for the pump, and for that grinder risk. Is that accurate?
Right.
Nice.
Right.
That's really powerful.
That's a good entry point. And then from here on, once we have gotten this, kind of like right in the face view of our assets and what we should be looking at, we can then visualize some other parts from the model. So here are these profiles that you were talking about, but we have a high failure examples label here just to describe to the end user what this information really is, and that's what I understood, that this is creating examples of the type of signals and the things that contribute to potential failure or that could make the chances of that failure higher.
Yes, and if you could can you click on grinder failure real quick, just because I was just working with that model out of curiosity?
Sure, absolutely. Maybe you're looking for some of these.
This is nice. I like how you put it as high failure examples. I think that makes a lot more sense than my explanation of prolific statistical examples, right? I'm sure a service manager doesn't really care about that. So this makes a lot of sense. So I can see, I actually like that line that you put in there too, to make sure that it's, when this happens and this, how it's down selecting. That looks really good. This is really nice. And I think especially as I think the first tab, the machine service tab, is really great because it, gives a full view of, hey, I come in the morning, I have 1,000, if I'm like the service manager for those, different 1,000 machines right away, right, I can see, hey, I want to go see, which of my machines are at high risk of failures. I know there's 3 critical elements. I built these models. They're being scored in the morning. Of course, they can be scored more frequently, but let's just, in this case, a batch scoring job. Before I come in the office, the models are scored, and I can see, wait, anything that's very high regardless, right, I want to make sure that I'm acting on those because that has the highest likelihood of failing. And if I want to drive proactive service, right, and that predictive level of maintaining my equipment, I want to understand those things that are high risk first. And I like the coloring too, right? It gives another thing of, hey, anything that's in red, right, is me as a service manager, I need to prioritize these. So if I'm delivering proactive service, I can now start optimizing who's actually going to go out there, what calls are we going to make to these clients to say, hey, when's a good time to do, this, that, or the other thing to make sure that this thing does not go down. So that's really nice.
Sure, and talking about colors and pulling the attention, I'll jump into the machine scoring tab, which kind of shows a little bit more of that detail that might provide more information to someone who is a little bit more experienced in the matter. But here we have a prediction of failure. So again, even in this view, for this particular user, we're employing some common concepts such as, color coding and image coding to drive the attention.
So let me just, no, that's really nice. And just to clarify, Sveta, so that little guy there, right, who has the sign, these are, ultimately what I know is that the score, right, of a predictive model that I just built, right, is a probability. So it's a numeric value. So did you set a range for different types of risks? So even in the beginning, when I say high risk or low risk, right, I know that my model is giving you a number. So I guess that must mean that you set a business rule, right, based upon, when it's between this range and this range, right, that this is a lower risk or higher risk. Is that accurate?
That sounds about right. I mean, we can really pull any number from the model and add the particular visualization, but that's about right for this particular view.
Yeah, and I know. I think it's good because ultimately, like, I don't know that if I'm running this espresso company that's responsible for service, right? Do I want to leave it to every individual to make their own decision of which probability is a higher level risk, right? As a manager, I want to make sure that that range is defined, and I want to set the rules for, hey, what sort of probability of failure is high risk in my opinion? I think that's awesome. So setting a range of those probabilities and then associating it with a risk level and even a color, right, makes it really actionable, right? I know if I'm looking at this observation, this date, right, this score, and this particular machine, and I'm getting here, based on all these conditions and this IoT data coming in, if I have a low probability of failure, I can move on, right? Which is fantastic. Oh, wait, here we go, right? Now I have an indicator or a signal or a flag that's very high. I think that's fantastic.
Right, and the only tab that we haven't gone into here is the prediction model. So in this case, we're pointing out those, I believe these are the signals that contribute the most to this particular prediction.
So so just real quick, I think there might be a little lag. Right now I'm looking at the estimated model accuracy. Is that accurate?
Yeah, so we were looking, in the prediction model tab.
No, so this is perfect. So these aren't the signals. These are what the model created and showing the algorithms. Now, I think that what I like about each of these tabs is that it's probably a different persona for each tab. It can almost be its own application, and I think this is really for just the analytics group to use the same sort of application to say, okay, the models I created, this is the accuracy I feel comfortable with, but I want to know the algorithms that were being used, and I want to see some of those accuracy metrics. I think these are the right measurements to expose and the right things to show. So I'm very comfortable with this.
Okay, so we have about 4 different tabs where we expose different portions of the prediction model that can serve different personas. So the owner, the service technician, the data analytics person. Anything else that we need to do here? I can actually make sense of this, even though I'm not a data analytics person, but I think this kind of really explains the type of things that we need to be looking at and the type of things that matter to the uptime, let's say, of our machine.
No, I think this is really, really awesome and robust. I think you did a great job. So, I think this really resonates. Yeah, I think you're absolutely right. The machine service tab, right, that'll tell you across the machines what's going on. I think as a service manager, I want to see what's going on and driving performance across all of it. As someone who may be more of an analytics person or developer, I want to understand the accuracy of my predictions in that prediction model tab. And then as someone as an actual service technician on the ground, right, and if I'm responsible for one particular machine, I want to see details about a given machine and what's driving that prediction. So I think that is, I think across the board, it's the right personas for this company. I think that, these models and using the analytics capabilities to build it in the power of ThingWorx to bring all this connected information together and use it to be able to calculate a model that we built and operationalize that analytic output in a way that is meaningful. This is the name of the game, right? This is what IoT analytics intelligence looks like.
Great. So
all right, fantastic.
Back to you.
Yeah, so I'm actually, I think really just to kind of sum it up before I hand it back over to you, Clint, and I'm going to fast forward this slide here real quick.
I think next.
Right.
Yep.
What I wanted to show here, right, is what does visualization mean, right? I can build a model, right? I can see, what's going on in that model as a developer, but if I can't understand the context, the different types of people that are going to make use of that. In this case, we had, these are espresso machines, but we saw a use case that's driven by service, right? And we even talked about different ways of understanding that information from a corporate perspective. What does a service manager care about? What does a technician care about? How does the logic created from historical information and then operationalized, right, to have new information or IoT data coming from these connected machines against that model to drive a calculation, meaning, context, right? There's there's a lot of complexity in terms of how we developed that. Now, we simplified and automated it with some of the capabilities, but there's a lot of moving pieces to that puzzle, right? I had to build a historic data set. So this is in collaboration with this company. So Sveta and I as developers, myself from an analytics perspective and Sveta from a UI visualization perspective, right, we had some requirements, right? We appreciated the fact that this company has invested in an IoT strategy, that they had devices connected. They were able to provide us a historic view that I could create a model to understand failure in 3 different components. And then I was able to understand that model, right? And then the question is how do I bring this together, this connected information together with this model that I've created? And that's the power of ThingWorx, right? It's the power beyond, right, just here's an analytics tool sitting in silo, here's my IoT connectivity, here's my visualization tool, right? I can bring that connected information together. I can understand it in context. I can create the logic and operationalize that logic to drive calculations. And then with all of that information and that rich analytic output, those insights in the data logic insight paradigm, right, I can use the power of flexible visualization to be able to create an interface for consumption of powerful outputs in a way that drives understanding and thus action upon it. That is a powerful paradigm. And fundamentally, this is why people on my team in the analytics space, right, in general, I think that it is so important to realize that everything we do in the IoT is an analytics exercise, right? Even if it's not predictive analytics, logic is critical, right, to being able to understand the data that we're reading and understanding. So, we always tell our customers that IoT is analytics and analytics is IoT, right? That's the nature of digital transformation in the digital world. Right? Yes, analytics is a journey that relies on a spectrum of capabilities. You saw one example of ours, our machine learning capabilities today, the ability to create a supervised machine learning model and operationalize it. But there's more than that, right? There's intelligence that lives in every part of the enterprise that may have meaning. And if we think about the business problem we're trying to solve, just like we need to do in analytics, just like we need to do in IoT app development, we can make the most, right, of being able to take what has already been built and put it into meaning. Just like I did with that analytics model, what if you have simulation that traditionally is only in one design team and 2, physics-based people are sitting there in the testing phase of that product? Well, maybe some of that simulation and the powerful intelligence that's calculated has meaning in other contexts. Maybe I want to call upon that in a lighter form or a replay, right, if there's certain hypotheses that were tested there that I want to see in operation. Well, the power of ThingWorx in general is the ability to operationalize that intelligence and make meaning of it even outside of the context in which that intelligence was created, right? When I operationalize intelligence, those analytic outputs are not just for the people that created that intelligence. In fact, if we can allow for those analytics outputs to be consumed by the widest variety of people, that is what drives a pervasive analytics and IoT strategy across the organization. It maximizes consumption, right? And the power of visualization is we saw 4 different contexts, right? The game 10 years ago in analytics might have been, hey, I'm one company that provides one type of view, right? And what we learned is that, what people need? They need a different way of seeing something. That in fact, right, it's not one variety of something that drives consumption. It's an acceptance of the diversity that drives consumption. You need to have the same information and integrity at a data and a logic level. That's the power of being able to create a predictive model. That's the power of having an application enablement layer, a Thing model. But without that flexibility to expose that powerful information in flexible, diverse ways doesn't take into consideration the fact that each user is not going to want to see something in the same way. And the power of what Sveta showed, right, in those 4 different slices of data and expositions of that valuable information in terms of, those different dashboards and applications, right, is that they're powerful to a completely different person. It's the same model, the same information, but 4 different views and contexts that are completely provide completely different value to 4 different people in an organization, right? It's the acceptance of that diversity in terms of how you need to consume something in context that will allow for pervasive consumption of analytics. So with that, I always say, start your journey now, right? Iterate, go through this process. Work with, realize it's not this kind of stuff in this space, whether it's industrial IoT, whether it's advanced analytics. If you think that, if we think that we can solve this problem for companies and customers on our own, right, is silly. It's a team effort, right? Without people, my expertise is, going to be focused on statistics. I would love to have spent this entire time talking about, learners and algorithms and what that model means. But I need someone like Sveta to say, okay, great, but here's what we're delivering on, right? Here's what it actually means to the customer. What you're talking about right now does not matter to a service manager. So as Sveta would even say to me outside of this, Chris, that's absolutely fantastic. No one cares except for you, right? I need that personality to say, let's make meaning of it now, right? It's that collaboration, right, that brings something together that actually can drive transformation for end customers. So with that, I will close it out. And I'll hand it back to you, Clint, and we'll take questions.
All right. Thanks, guys. One last note before we do open up for Q&A. If you are interested in getting more familiar with this technology, we'd encourage you to go check out our developer portal. Once you sign up, there we'll provide you a 120-day trial of ThingWorx Analytics. Plus, we offer various guides that will help you get up and running really quickly. So if you do have any questions, please feel free to submit them now through our Q&A pane. We actually do have a couple questions that have come in already, so we'll get started with these. So Chris, you mentioned several other analytics programs like R. How would ThingWorx interact with R?
Yeah, so let me answer that in twofold, right? From ours, so certainly we have, even across my team, we have people that use R, people that use other tools, right? So there's different reasons that you would use R. So even if you're using R, say you're using R to build a predictive model, right? Let's say that's the only use case. So one is that you can use R to interact with data and be able to load it into our analytics server, even outside of, Analytics Builder, which I showed you. So we, have people that do that all the time. One, you can, interface and script, within ThingWorx itself to run certain types of calculations that you may drive in R. But also, you can, if you're even building a model, in R or any other tool, right? If you can export that model in PMML, which is the most standard, right, and you find it the most across analytics tools. Once you have that model built and you have it in PMML, you can use Analytics Manager, that tool that I touched upon, and then someone like Sveta can use those models that are within Analytics Manager to operationalize them, to define data coming in from the Thing model that's being scored against models created elsewhere, and then be able to manage the calculations and drive analytic outputs across, visualization. So even just from an analytics perspective, we have not only, do we have integrations and you can use R in lots of ways, but we don't believe in moving someone off a tool of choice. I don't think you'd be a good development platform, if you weren't open and willing to be able to allow developers to leverage what they're comfortable with. So not only can you use it, but I would say, most of the tools that you may want to use, the best and first option is how can I continue to use them and leverage ThingWorx to augment, my work with those tools. So absolutely.
Okay. So how do we go about creating or getting JSON and CSV data for analysis?
So when in creating, in terms of, I'm going to read the question as in terms of creating that historical data view. For that, say, when you load that data up into ThingWorx Analytics Server. And I'll be the first to, so that descriptive, so there's two different ways of data, right? There's creating a descriptive view in what you're using to create a model, and then there's operationalizing that model. On the operational side, right, what we showed is data coming from the Thing model being scored against, right, the actual predictive model that's created. But in terms of that descriptive wide view, frankly, you would use the tool of choice, right? I wouldn't even say you would use, ThingWorx for that, right? Because there's a million different types of ETL tools out there. I'll be the first to say that, you have to create a statistically ready, clean data view. Garbage in, garbage out absolutely applies, right? That data set that I created, that CSV file, right? In my case, I used Excel. In other cases, right, like my colleague or Sveta and I's colleagues would use R for some of those tools, right? Or any sort of ETL or data wrangling tool to create that descriptive view. But you have to bring it together in a way which describes the problem. There's a number of different tools to do that, but I'm the first to say that, data cleansing, and you have to get that data wrangled. And again, just like analytics, it's right, having the maturity to recognize that you do it is a big enough leap. I would say that if the organization has preferences or the people within the organizations have preferences, and there's probably more than one, leverage those to be able to create that representative or descriptive sample of data to load up into the analytics server.
All right. Are you able to go into more detail about how we could connect the machine to the ThingWorx analytic model and define data coming from the machine to create the models?
Yeah, so that's really the power. When I say Analytics Manager, that's an interface, but really it's just a framework for operationalizing models. So absolutely. We can actually, if you go on to the Dev Zone, recently we actually have an entire guide now. Is that, correct me if I'm wrong, is that launched?
Yes.
Yes. Okay. Great. So I have additional Dev Zone support behind me, but yeah. So we actually have a great guide that can walk you through exactly that. So going from literally, here's a model, whether that model is created in ThingWorx Analytics that you saw or elsewhere, it will walk you through exactly how to do that, how to take data coming in, how to define it, and then how to drive scores against it. So I think you can do it within about a half hour, right, within that tutorial? So yeah, within a half hour, not only can you understand how to do it, but actually do it.
Very good. So obviously, you know that feature engineering is a key part of the data analysis process. Do the ThingWorx algorithms do a little bit of feature engineering internally?
Yes, they do. Yeah. So absolutely. So there's feature engineering in terms of creating that descriptive view that I was talking about, and again, these analytics terms can be used very loosely and have a lot of different meanings. But there's feature engineering in terms of getting a data set just ready to be understood that makes accurate sense, right? And that's kind of what I generally consider, data cleansing and really data wrangling, right? But then there's in terms of, hey, when I'm modeling something based on that descriptive view, right, the things that you saw before about like signals and profiles, right, from a data science perspective, things like MI and those features, right, help and enable a modeling process. So just like in a manual process, if say you're not using automation, right? You are generally going through and trying different processes, and you're trying to narrow the feature space a little bit to make it more consumable. The automation our technology provides is being able to automatically sift through that and use the feature space to guide, right, the automation and selection of algorithms based upon that. So just like the reason that you see things like signals and profiles as an analytic output from creating the models, because we're doing it anyway, it provides value, but it's part of that process because it's using some of that feature understanding, right, and feature exploration in the guiding principle and process of selecting the right base learners and ensembling technique to create that ensemble model, or depending on another technique that you use that you're operationalizing. So absolutely, not only that, but that feature, enrichment is part of what is really powerful about our supervised machine learning capabilities.
All right. So this is a great presentation, but how do I go about incorporating event styling and inserting things like animations and responsive behavior like in the demo you showed earlier?
That's for Sveta.
I do apologize, Clint. Do you mind repeating?
Sure. So this user was looking to incorporate event styles and animations like in the demo you showed earlier with Chris.
Oh, sure. The very standard way to achieve these things in ThingWorx is by using the media entities, style, and state definitions. A lot of widgets such as the value display, the shape widget, and some other widgets out of the box have the ability to take a state definition. So you can apply your variety of icons, let's say for different severity of a predicted risk, and just create them as style definition and drive them from your data. So in our demo, in the data set, the mashup is pulling from the model, let's say, the accuracy or the severity of the risk. And how we handle that in the mashup is we bind state definition to it, and it's updated every time the service is refreshed or you change your selection, or a risk just becomes present. The model identifies that there's a change in the risk, and that automatically gets visualized because the widgets are ultimately, and the state definitions are ultimately driven from your data set. If you'd like, we touch on that in the second installment of this webinar series, where I cover some of the basic out-of-the-box widgets, including the value display, and there I show how you can add an arrow to show the trend for your, let's say, value. And additionally, you can also take a look at the third installment of the webinar where my colleague Gabriel Bukur talks a little bit about, not a little bit, talks about CSS, the CSS capabilities in 8.2. So if you are familiar with coding, this is for the coders out there, you can also utilize the CSS capabilities to, let's say, replace images or change color text, etc. So that can be done either through the codeless environment with our widgets and entities, or you can control that with code through JavaScript or CSS. And again, you can definitely reference the two previous parts of this series and get more information.
All right, and one last one for you, Sveta. In closing, do you have any recommendations for how you could guarantee consistency in the application in terms of overall design?
Sure. So this is sort of an advice for non-designers. What I recommend to non-designers in order to keep your design and style consistent is to manage well your style definitions. For example, let's say even in a simple text editor such as Word, you have preset styles for a header, for title, for grid. So stick to, define your styles and stick to reusing them. Don't have 5 different label style types or 5 different styles for showing, let's say, the number for your model accuracy. So limit, let's say create 5 to 10 styles for text, and from then on define a few colors that you would be using throughout your application for buttons or for label charts or time series charts, those elements where you have, where you need more of a vibrant color, and just stick within those to give yourself a limit to the number of styles, the number of colors, and different text sizes that you can use. And ThingWorx is great for that. You can duplicate the default styles and use them as a guide. So we have one style for labels. We always have one style for grid headers, etc. So you can just duplicate a few of those, change the colors as you wish, and keep reusing them throughout your application. Just keep reusing your styles. That would be a general good point.
All right. Thanks, Sveta. That is, unfortunately, all the time we have for questions today. As I mentioned earlier in the webinar, we will be following up with each of you if you do have any questions, so bear in mind that your inquiries will be addressed. I'd like to thank you all for joining today. We will also send a recording of this webcast once it's available. From there, you can actually access all the other webinars in this series as well. If, like you said, you want to reference our more about CSS or the collection widget or things of that nature, that will be made available to you along with all the entities in those sessions as well. But if you do have any additional questions, please feel free to send us a note via our contact form on the developer portal. Other than that, I hope you found today's session valuable and will join us again for one of our future events. Thanks, everyone.